Chloe might want to hear this, and Tia, and Liana. So the SBAC, it's all on the computer, right? You cannot sit there with your own calculator. If a question allows you to use a calculator, the calculator icon will appear. You can click on it in your computer and then work through it with the calculator, right? If it does not give you the icon, you got to just figure it out. You got to just do it, right? You cannot bring your own calculator, and there's going to be nothing on the walls that can help you out, right? No math, anything, no number line, anything like that, okay? So how can we simplify a square root without a calculator? Let's find out. Starting with number 3, okay? If I have the square root of 5, is that a perfect square, the square root of 5? No. What's the closest perfect square to the square root of 5? Square root of 4. What's the next largest perfect square? 9, right? So the square root of 5 is somewhere in between the square root of 4 and the square root of 9. Everybody with me? What's the square root of 4? What's the square root of 9? 3. So it's somewhere in between 2 and 3. Does that help me answer this first question? No, because 2.9 is also in between 2 and 3. The question is, where between them are these numbers? 2.9 is pretty close to 3, isn't it? Right? The square root of 5, is that closer to 4 or closer to 9? It's closer to 4. So if I'm thinking in terms of a number line, the square root of 5 is going to be somewhere over here. I don't know exactly where, but I know that it's definitely less than 2.9. Right? I don't need to know exactly what the square root of 5 is, because I'm logically deducing where is it in relation to 2.9. You guys get what I'm saying? 2.9, that would be something like the square root of 8, right? Well, the square root of 5 is definitely less than the square root of 8, so this one's got to be true. You guys get me?
Yeah.
What about the square root of 23? What's the closest perfect square to 23? 25. It's slightly more. 16 is a lot less, right? So this is between 4 and 5. 23 is pretty close to the 5 range, right? Maybe somewhere in here. We could say is the square root of 23. Well, I'm comparing that with 4. That's right here. Is that more than 4 or less than 4? It's definitely more than 4, so that next one's got to be false. You guys following along? Yeah? Now this is a good one. The square root of 30. A little bit less than 36, a little bit more than 25. So it's somewhere in between 5 and 6. Well, this is 5 away from 25, 4 away from 36. So it's going to be pretty close to the middle of 5 and 6, wouldn't you say? Maybe slightly more towards the 6 side. Let's call it 5.6. It's not quite 5.5, it's a little bit more. Let's just say it's 5.6. I didn't use a calculator for that at all. But if we plug that in, we should get something at least relatively close to 5.6. Well, if I have 5.6 over 5, if I have 5.6 over 5, right, compared to 7 over 5, well, hey, those have the same denominator. I can just compare the tops. Which one's bigger, 7 or 5.6? 7. So that must be true. You guys picking up what I'm putting down? Okay. Number 4 is gross, isn't it? Anybody figure out number 4? No? Maybe? Well, let's take a look at the square root of 1.35, right? What's that the closest to? What's the closest perfect square to 1.35? 1. Well, what's the square root of 1? 1. So 1.35 is going to be slightly more than 1. Let's say, just for the sake of argument, that it's 1.1. All right? What is 5 minus 1.1? 3.9. So now I know I'm looking for the expressions less than 3.9. Or less than 4, we could even say. Okay? Pi. What does pi equal to? 3.14. Square root of 2 is really close to the square root of 1, right? Let's call it 1.4. Why not? Matter of fact, let's just ignore the decimals. What's 3 over 1? 3. That's definitely going to be less than 3.9. So that one works. Right? We're so used to just plugging in our calculator, getting a really long, ugly decimal number, cutting it off, and knowing right away. But we don't need to do that to answer these questions. The way the questions are phrased and worded doesn't require you to use a calculator. Some of these you might get the calculator icon and makes your life easier. But if we don't know how to do it without, then we're not going to be able to do well. 5 over root 3. What's root 3 really close to? Root 4. It's more than 1, less than 2, but it's closer to 2. Let's call this 1.8. We could call it 1.7, we can call it 1.9, it doesn't matter. 5 over 1.8. Well, how many times would 1.8 go into 5? Like 2.5 times or something? Even if we say, let's just call this 2, right? 5 over 2 is 2.5. Is that less than 3.9? Yes. Now what about this one? 2 root 2. 3 plus 2 root 2. Well, what is root 2 about equal to? It's like 1.4 we said. What's 2 times 1.4? 2.8. What's 3 plus 2.8? 5.8. Is that less than 3.9? Nope. 4 plus 8 over root 50. Right away, I know my answer here, right? Is that one going to be less than 3.9? No, I don't care what I'm adding to 4. It's not going to be less than 3.9 unless it's a negative, right? So that one goes away too. Right? Deductive reasoning is what the main idea of the SBAC testing is. Yeah, it's testing if you know the math concepts and stuff. But can you use the math concepts that you know to kind of like work your way around? It's a very much less explicit way of doing these things, right? Closest approximation to root 51. Well, what's the closest perfect square to 51?
7 times 7.
49. And 64. Is it closer to 49 or closer to 64?
49.
Closer to 49. So it's going to be a little bit more than 7. Right? Square root of 51 might be 7.1. Closer to 7. Okay? And this type of thinking is really helpful when we get over to something like this, right? 25 minus 4 plus 16, what is that? 21 plus 16 with 37? Right? What's the closest perfect square to 37? 36. So I could say that 37 is between 6 and 7. Does that help me figure out what my answer is? No, because I've got 2 options there that are between 6 and 7. But because 37 is much closer to 36, right? If I pull up a number line, 37's right in here. So that's going to be really close to 6, maybe 6.1. Hey, look at that. Now I know that it's going to be A, because B is way too high, right? Number 1. Anyone have an idea on how to figure out number 1? Alex?
Just by trial and error.
Trial and error? Good. I love that. That's going to take forever. Aldrich?
I just remember it.
You just remember it? Do you remember the process?
No, I just, play with the calculator sometimes.
Oh, really?
Yeah.
That works. If you have done that before, that would be great. Here's how we can figure this out without a calculator, without playing with a calculator in our free time, and without just trial and error, okay? Follow me with this because it's a little bit wacky. 0.44 repeating, right? Let's say that x is equal to 0.44. What is 10x?
Oh,
4.44 repeating. Everybody with me on that?
yes.
Okay. What is 10x minus x? Well, that's 4.44 repeating minus 0.44 repeating. What is that equal to? 4. Right? What is 10x minus x? Well, that's 9x. These are now the same thing. 9x equals 4. How can I get x all by itself? 4 over 9. Let's go to our calculator. 4 divided by 9 is 4 repeating. 0.444 repeating. But you can't use a calculator. But we didn't use a calculator to get that answer. We used it to check to make sure it was right. But I got this. It says what? Write it as a fraction. Use only whole numbers. 4 over 9. Those are whole numbers. Alex?
Why specifically use 10x?
Why use 10x?
Yeah.
Because we want to move this decimal. We want to manipulate this to where we're canceling out the repeating decimal, right? So if I were to, subtract this equation from this equation, I end up with 9x equals 4, right?
Yeah.
But what if I didn't have a repeating decimal like 4, 4? What if I had a repeating decimal like 0.3 what? Give me a number. 2. Sure. 0.32 repeating. Well, let's say x is equal to 0.32. I can't move this decimal one space. I want to move it 2 spaces. So I'm going to do 100x. 32.32 repeating, right? You guys see that?
Yes.
Well, if I do 100x equals 32.32 repeating minus x equals 0.32 repeating, what do I end up with? 99x equals 32. How can I get x all by itself? Divide by 99. Watch this. X equals 32 over 99. Is that a fraction of 2 integers? Yeah. I'm looking for 32, 32, 32, 32. 32 divided by 99 is 32, 32, 32, 32, 32, repeating forever. Yeah. Great question. Why did I make this one 100 instead of 10? Because we weren't just repeating one number, we're repeating 2. 3, 2. Before we were just repeating the 4, right? 4, 4, 4 forever. So if I'm repeating one digit, I got to multiply by 10. Two digits multiplied by 100. What about 0. Someone give me 3 numbers.
375.
375. And what if they're all repeating? 375, 375, 375. Well, now I need to multiply by 1,000. 375.375 repeating. Right? So now I've got 999x equals 375. So x equals 375 over 999. Let's check. Does that give me 375 repeating? Come on. 375 divided by 999. 375, 375, 375, 375. Okay? I can almost guarantee you there will be a question like this on the SBAC. So now you know how to do it. What's that?
Can you remove that question, please?
Can I remove it? I don't have any control. If I did, I'd remove all the questions and give you a good time.
Should go farther with there and like all the.
We'll go over the back tomorrow.